Which is that we're talking about?
Where's Hannah?
Hey, maybe we're gonna look at the sideboard here. Fun Sock Friday. Odd 1 SWBA. What's that stand for? Ray.
Students will be able to.
Very good. Students will be able to the TSI recognize and factor special cases of quadratic section 7.5.
Special cases.
Your hair looks so dark today.
Okay.
That is not fair.
Hat hair.
It looks so
It is higher.
You should draw it.
What do you mean it's hatter? Look at mine.
I can see it from the
Bedhead.
No, mine is literally
Oh,
hat hair.
that's like. It was literally standing like this morning.
What I mean by it's hat hair is that it's hat hair.
Like he literally took his head.
Who do you know?
I took a hat off, kind of fixed my hair like a little bit, and called
No, I
it.
did. I put a hat on, and then I
All
went to
right.
bed again because I go to bed.
We have the special thing called a difference of two squares. We talked about it a little bit. We talked about difference of two squares a little bit last chapter when we multiplied things together. And then we ended up getting a squared minus b squared. You guys remember that? When we had something like a minus b times the quantity of a plus b, the same thing in both parentheses, but one was positive, one was negative. You guys remember that? Okay, that was a big thing. We can treat a difference of a squared minus b squared. The difference of two squares. A squared is a perfect square. B squared is a perfect square. Take the subtraction of the difference. Difference of two squares. Mathematics head up. Like the middle term is a 0. You remember that question on the homework a couple days ago, where what was the middle term here? And it was 0? Because this is really like x squared plus 0x minus 16, right? Go ahead and write that with me. Now we can do this the same way we've been doing it by making our x. The trinomial we make our x. What goes to the top of this x? What kind of 16? Negative. And what goes on the bottom? 0. A negative number that we're multiplying to, so what do you know about our signs? Negative and the positive. So what two factors of 16 have a difference of 0? What are factors of 16? 1 and 16. 2 and 8. 4 and 4. What's 1 and 16? What's the difference between those? What's the difference between 1 and 16? 15. What's the difference between 2 and 8? What's the difference between 4 and 4? 0. Negative 4, positive 4. Negative 4 times positive 4 is negative 16. Negative 4 plus 4 is 0. So now, according to our shortcut, since a is 1, what can I write for my shortcut in my two parentheses? X minus 4, x plus 4. And that's my answer. Did we do anything different so far besides call the middle term 0? No. We said the middle term was 0, and we did the same thing we did last section. How many guys tried y squared minus 36? Do the same thing like we just done, x squared minus 16. Zooming out, sorry. Mr. Grouse, nice to meet you.
You're funny.
I know. Thank you, though. Oh, yeah, I was looking at the wrong spot. Over Tagmatics. Thanks, buddy.
Yeah, thanks, buddy.
You want to check? Sure. Oh, buddy.
What do you mean? What does that say? Oh my gosh. So what are you check? I'm so confused.
No, and you're strong.
I know. Yeah, once I said it, I was like, okay. Can you help me?
So negative 18 plus 18, that multiplied 36. So what are numbers that multiply to 36?
stayed up and I literally sat there and zoned out for a solid 2.5 hours. I have a tattoo with
Okay.
that.
Yeah, I'm forgetting.
Science. Yes.
Let's talk about this one up here. So our middle term ends up being 0 again. Y squared plus 0y minus 36. Take the x, negative 36 at the top, 0 at the bottom. Multiply to a negative, so they have different signs. Back to the 36, you got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now, for them to be a positive and negative, that means they have to have a difference of 0. Well, 6 and 6 are the same numbers, so they have a difference of 0. So we're able to write y minus 6 and y plus 6. Now, guys, are we noticing that this is kind of the same thing we started with before, and then we multiplied together and got the difference of 2 squares? You guys remember that from last chapter a little bit? Okay? So we're saying this is going to be a pattern. Difference of 2 squares. We're going to call it dots. Did everybody understand how we got dots from difference of 2 squares? If you don't look, D-O-T-S, dots. Difference of 2 squares.
Macman.
So if you start out with a difference of 2 squares, a perfect square minus a perfect square. In this case, x squared is a perfect square because x times x is x squared. Is 16 a perfect square? 4 times 4. So if you have a difference of 2 squares, 2 perfect squares subtracting, you can skip this part, and you can skip this part and go straight to the end. Because all you have to do is take the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. In this case, what's the square root of x squared? What times itself is x squared? X. That's what I mean by square root. What times itself is that number? The square root of x squared is x. What's the square root of 16?
4.
4. Square root of the first minus square root of the second. Other parenthesis, square root of the first plus the square root of the second. Same thing here. Y squared is the perfect square. 36 is the perfect square. And we're subtracting. Square root of the first minus square root of the second. Square root of the first plus square root of the second. That's your two parentheses every time. We can always still go about it this way, where we write the middle term as 0 and keep going. You can also do that. There's nothing wrong with that. This is faster. So we keep it. We're going to practice this. Now, does it actually matter whether you put the minus first or minus second? No, because you don't care about the order the parentheses are in, as long as what's inside the parentheses are the same. Yeah. Okay, so let's go ahead and flip our page here. Now, in order to be able to catch the difference of 2 squares, we need to know our perfect squares. So we're going to practice them real quick here. So, if the square root is 1, what is 1 times 1? What's the perfect square? 1. What's 2 times 2? 4. So 4 is the perfect square. The square root of 4 is 2. Raise your hand for 3 squared.
9.
Raise your hand for 3 squared. Matthew. 9. Raise your hand for 4 squared. Presley. Awesome. Raise your hand for 5 squared. Ray.
25.
Raise your hand for 6 squared. Levi.
36.
Raise your hand for 7 squared. Presley. Awesome. Raise your hand for 8 squared. Presley. Dope. Raise your hand for 9 squared. Okay, let's go Presley again. Anyone, you're feeling it. Okay? Presley, you just keep going as long as you want. 10 squared. Okay? 11 squared.
121.
Oh, okay, Presley. Okay, 12 squared. No, you're good, okay. Let's do a crowd. Nope. 144. Let's want to try your luck again. 113 squared? Okay, you're tapping out, okay? Anyone else 13 squared? 169. 14 squared. 196. You take 13 and 14 squared, you flip around the last 2 digits. 15 squared. 225. When I was in high school and taking Algebra 2, I was saying algebra 2, we had to memorize the first 25 perfect squares. Yep, we had to quiz over it like every other week.
What's 24?
576.
Well, you could say random numbers.
Yeah, that's true.
That's
You
true.
don't really know.
I mean, I'll show you guys real quick. 24 haha times 24 haha. 4 times 4 is 16. 4 times, or carry the 1. 4 times 2 is 8. Plus 1 is 9. 0. 2 times 4 is 8. 2 times 2 is 4. Add them together. 6 plus 0 is 6. 8 plus 9 is 17. 1 plus 4 is 5. 576.
Dang,
That's impressive.
dang, son.
You can make us memorize the first 15.
No, but it's helpful too.
Didn't we have to memorize like the first 15 last year?
Yeah,
We
obviously
had to
didn't
memorize
work
the
very well.
20.
We didn't no, we memorized 10.
She made us do a quiz on it.
I know, and I got it right, but like, I don't remember it. I don't
So
remember the 20.
She's like, it's gonna be super hard.
Now, hey, don't forget, we're always going to check for a GCF first too on these, okay? That can help. We always check for GCF first for every problem we do for factoring. X squared minus 100, how many terms do we see there, guys? 2. So whenever we see 2 terms, our mind should be keyed in and say, we should look for a difference of 2 squares if it's there. Is X squared a perfect square?
Yes.
Is 100 a perfect square?
Yes.
Are we subtracting?
Yes.
Do we have the difference of 2 squares? Yes. So what do I write now?
X minus 10 in parentheses and then X plus 10.
Exactly right. I do the square root of the first, X, square root of the second, 10. Square root of the first X, square root of the second, 10. In the first one we do subtraction, second one we do addition, or vice versa. Very good, Ray.
Oh.
Question over that first one. Okay, once again, you could also go that longer way and make the X and have the middle term be 0x. Once again, on number 2, do we have 2 terms?
Yes.
So we want to look for perfect squares. We want to see if we have a difference of 2 squares. Is X squared a perfect square?
Yes.
Is 4y squared a perfect square?
Yes.
Yes. Okay, what's this? So what do I put in my parentheses?
X minus 4.
X minus
X
2,
minus 2.
y, and x
Plus 4, 2,
plus 2y. Because what's the square root of, how do you get 4y squared? 2y times 2y. If I took this 2y times 2y again, 2 times 2 is 4, y times y is y squared.
Oh, wait.
So in order for this 4y squared to be a perfect square, the coefficient has to be a perfect square, and the variable has to be a perfect square. So 4 is a perfect square, and y squared is a perfect square, so 4y squared is a perfect square. Okay. On number 3, how many terms do we have? 2. So we want to look for a difference of 2 squares. X squared, is that a perfect square?
Yes.
Is 16 a perfect square?
Yes.
Do we have a difference of 2 squares?
Yes.
No.
Why not? It's addition. Well, let's go. We haven't learned addition thing. Let's try this. Let's make our x. Okay. Our middle term is what, guys? 0. X squared plus 0x plus 16. So it goes to the top.
16.
It goes to the bottom.
0.
Now, how do we get to a positive number by multiplying?
2 negatives.
Either 2 negatives or 2 positives. Well, it's 0. So let's just say there's 0 can't be 2 negatives. Well, wait.
Positive.
Factor of 16. Thank you. 1 times 16, 2 times 8, and 4 times 4. Will any of these add up to 0?
No, you need negative and
You need a negative and a positive, but can we do a negative and a positive?
No.
No, because it multiplies to a negative.
So it's,
So this one's prime. And the reason why it's prime, guys, is it's a sum. There is no sum of 2 squares. There's no sum of 2 squares. Anytime you have a sum of 2 perfect squares, it cannot factor. Anytime you have a sum of 2 squares, it can't factor. Sometimes you can get a GCF still, but you can't go any farther than that. Questions on that? Okay, continuing on! On number 4, how many terms do we have?
2.
2, so we're looking for a difference of 2 squares if we have it.
Yes.
We want to check for a GCF, but I don't think there is a GCF here. Is 16a squared a perfect square?
Yes.
Yes. Is 81b squared a perfect square? Yes. Are we taking the difference of 2 squares?
Yes.
Yes. So what do I write in my parentheses?
6 or 80 minus 9b,
Yep.
and then 4a plus b.
4a plus
9.
9b.
9b in parentheses. Very good. 4a minus 9b, 4a plus 9b. So we say square root of the first minus square root of the second, square root of the first plus square root of the second. Square root of 16a squared is 4a. 4a times 4a is 16a squared. Square root of 81b squared is 9b. 9b times 9b is 81b squared. And if we were to FOIL and check our work again here, we would see we'd end up getting a negative 36b and a positive 36ab. We get a negative 36ab and a positive 36ab in the middle. Let's zero out to get rid of our middle term. On number 5, is 27x squared y perfect square? No, wait, what might we have first then? GCF. Do we have a GCF between these two terms?
Yeah.
What do you think it might be? I think we do. Not 7. 7 doesn't go into 27. 3. It goes into 27 because 2 plus 7 is 9. We have the digits, and 3 goes into 9. Okay, and 3 times 16 is 48. Because 4 plus 8 is 12. 3 goes into 12. So we can factor out a 3. Can we factor out anything else though? What about any variables? Y, 3y. So what are we left with in the first parenthesis? 9x squared minus
16y
so we factored out a GCF. Now is that first step, is that any different than what we did in that first section, guys? No, we did GCS back in the first section, okay? Now, 9x squared minus 16y squared, how many terms is that inside the parenthesis? 2. Now is 9y squared a perfect square? Is 16y squared a perfect square? Yeah, so do you have a difference of 2 squares inside? Yeah. So just like before, we can keep going. Business is normal inside the parenthesis. We just have to have the GCF outside. So what do I put in my first parenthesis?
3x and then minus 4y.
Minus 4y. Raise your hand if you can tell me what goes in the second parenthesis. Raise your hand to tell me what goes in the second parenthesis here. Okay, go ahead, Levi. Not x over 3.
No, 3x add 4y.
Notice our pattern, guys. Everyone has the same numbers in the parentheses, but one subtraction, one's addition. Every time. And if we were to FOIL this back out, we'd get our answer, which is how we know we did it right. So why don't we see if we can set up a bit?
Go to the nurse.
Either we need to go to the nurse or we need to sit up. One of the two, okay? Okay, you can borrow someone else's.
You borrow mine, Dylan.
There we go.
Bring it back, Phil.
Good one.
Someone want to fill it out for me? Okay. Look at number 6 here. 16a squared minus 36b squared. Are those perfect squares?
Yes.
Yeah, but what do we always want to check for first anyway?
GCF.
A GCF. Do we have one? What is it? 4. What do we have left if we factor out a 4?
You have 4a squared minus 6, no, 7b squared.
Not 7. 4 times what is 36? 9. 9b squared. Now hey, inside our parentheses, 4a squared minus 9b squared, are those perfect squares?
Yeah.
Yeah.
Oh, yeah.
So now what can I write in my next step?
2a minus, wait a second. I'm looking at the wrong one. Minus 3b. And then 2a plus 3b.
Is that it?
No.
So 4 in the front, the GCF.
So could you do it,
Could we have started out the other way?
yeah.
I'll show you. Great question. Ray's asking, Mr. Castle, 16a squared minus 36b squared, that's already a difference of 2 squares. Could we have started from there? Could I have just done 16a squared minus 36b squared and said, okay, well the square root of the first is 4a minus the square root of the second is 6b. And the same thing, 4a plus 6b. Yeah, but do we have a GCF inside the first parenthesis?
Yeah.
What is it?
2.
A 2. So we factor a 2 out and we're left with 2a minus 3b.
So if they kick
Do I have a
you
GCF in my second parenthesis?
Yes.
What is it? A 2. I have to have another 2, and it's 4a, or excuse me, not 4a. Or rather, it's 2a minus 3b. So then 2 times 2 is 4 again. And so do we still end up getting the same thing?
much longer process.
Yeah, but it is a longer
But
process.
it does work.
But it does work. Okay, so we get the same thing, it's just a longer process, and we have bigger numbers. So if we can catch our GCF right away, we're better off. Questions on that? Okay, so we always, no matter what kind of factoring we're doing, guys, we've learned some different methods. No matter what kind we're doing, we always look for what first? A GCF, because it makes our life easier. Presley, do you like smaller numbers or bigger numbers in math problems? Smaller numbers, that's why we look for a GCF. Talking about money though, getting that paper, okay? X to the fourth, Y to the fourth. How many terms do we have? 2. Do we have a GCF?
No.
Okay. Is X to the fourth a perfect square? Yeah, what times what is X to the fourth? X
Squared.
X squared times X squared. Is Y to the fourth a perfect square? Yeah, Y squared and Y squared. So what can I write in my parentheses?
X squared.
Very good, Presley. And what do I write in my second parenthesis? Very good. X squared plus Y squared. Now, if we wait 1 second, though, what might we notice about our first parenthesis?
There's a
Not a GCF. If I had just been given this problem, could we do something with that?
square.
Or is that a difference of 2 squares again? Because we have x squared as a perfect square, y squared as a perfect square, and we have a subtraction. So guys, we have one more time, we have dots again. We have dots again here. Difference of 2 squares. We have the dots again. So what do I write in my 2 parentheses from this problem, from this part? Yeah. Very good. And then what do I do with this x squared plus y squared? Can we factor that out anymore? No, why not? It's prime because it's the sum of 2 squares. We said on number 3 earlier, and the sum of 2 squares is a factor. So we still have that multiplying with this, x squared plus y squared. Yep. So this is our final answer. So sometimes you have to take a careful look, guys, because after we do that first difference of 2 squares, we are able to continue going. So sometimes we have to be able, we are able to continue going, and we have to.
Wait, so why do you have to put the x to the second power plus y to the second power?
Okay.
Why do you have to put that one?
At the here, because it doesn't go away here. Because this is still here. Because we took this part, right? And I'm going to put it in orange, that way you guys don't think it's part of the problem. We took this parenthesis and split it into here and here. Just like we took this and split it here and
I have a
here.
question.
We were able to take the dots again and split it in 2. But this had to come straight down because it didn't just vanish.
What if we were to split the second one? Would it still be right?
Can we factor the sum of 2 squares?
So,
No, we can't. So we look back at number 3 and say we can't factor a sum of 2 squares. Everybody look back at number 3 real quick. Everybody look back at number 3 real quick. Remember that's the sum of 2 squares, isn't it? Just like this second part is the sum of 2 squares, so we can't factor that out anymore, so that's why that's left as is. We can factor out the first part because it's a difference of 2 squares, x squared minus y squared. Did that answer our questions? Any other questions? Ray, did that answer your question?
kind of.
Now, Ray, if we were to multiply this back through, we just multiply the x minus y and x plus y. All we would get is x squared minus y squared. But is that the original problem? No, that's why we need this here too still. Because if you multiply all 3 of these back together, then you get the original.
Okay.
That make more sense?
Yeah.
Okay. I'm gonna try number 8. Remember our first step always. If you have rough questions, raise your hand. Go a little bit more. Maybe even if you aren't seeing it, back up a second and reapproach it. If you're having trouble, back up and start again. And you can do more. If you're having trouble, try and back up and start again. Otherwise, maybe look at what I did on number 6 in the light blue. Yeah, check it there.
Oh, yeah.
Shoot.
Factor out bigger.
Wait, that's how I.
Factor out 2 up here.
Now look.
Factor out 2 here, you get another 2. Yep. You look at the light blue. So I had to factor out 2 up here and 2 up here. I had 2 times 2.
So, one, is this good so far then?
Well, let's probably take 4 out of this. Yep. There you go, there you go. There you go. Good. What happens if you take a 2 out of this?
Oh, yeah. Oh, yeah. That would be,
Very good. No, this 2 times. Let's try it.
yeah, it's good.
Well, we have to write the inside. That's like from your first step to your last step. What did you do to your very first step?
What?
There you go. There's like a dot at the very top. Like that. That's it. Awesome. Not quite right. Let's talk about this one up here. So, do we have a GCF before we continue?
Yeah.
Yeah, let's factor our GCF, make our life easier. What is a squared minus 25? You might notice that this is a difference of 2 squares already, though. Just like we did in number 6. But it's helpful if we find that GCF first, because now, is a squared minus 25, is that still a difference of 2 squares? Yeah. And what would I write in my 2 parentheses?
I got you.
Okay?
A minus 5.
Yep.
A plus 5.
Yeah,
4
because you do the square with a 4 on the outside. You do square root of the first a, square root of the second 5, subtraction. Square root of the first a, square root of the second 5, addition. One's subtraction, one's addition. We don't care the order. I think Victoria, you put addition and subtraction. That's perfectly fine. We don't care about the order. So we get that right. Now I know some people went the other direction, or they went the other route where they did the difference of 2 squares first, which can work. So they said, oh, 4a squared minus 100, that's the difference of 2 squares. 2a minus 10, 2a plus 10. Then we have to say, keep going. But a lot of times it can be hard for us to notice that we have to keep going. When we get to here, we're like, oh, we're done. But it can be hard for us to notice that we need to keep going, which is why I promote looking for the GCF first, as well as small numbers. We can actually factor out a 2 out of the first part, and we're left with a minus 5. And we say, oh, we can factor out a 2 out of here too. So we have another 2. We have to multiply them together. And that's with an a plus 5 rather. Now 2 times 2 is 4. And we still have that same 4 times a minus 5 times the quantity of a plus 5, which is the same answer. Ends up being a little bit more. It's harder to spot. It has bigger numbers, but it still works. Questions on that? So I always advocate, I always say, hey, let's see if we can find our GCF first. Okay, continuing on. We have these things called perfect square trinomials. Do you remember we end up having the x plus y squared or x minus y squared, and we had to write it twice and multiply and FOIL them together?
Yeah.
We did that last section. Okay, we're going to notice this is just going the other direction of those. So we want to look for this option in which a and c are perfect squares. If we look at this problem, x squared plus 10x plus 25. This is a trinomial, 3 terms. Is a perfect square?
Yeah.
Yeah, you have 1x squared. Is c a perfect square? Yeah, 25, ha ha ha. So we want to look for this option. So what's going to happen is as we make our x, what goes to the top? What goes to the bottom? 10. What kind of numbers are we going to have here? 2 positive. Same sign, so they multiply with positive. Bottom with positives have to be positive. So what are 2 factors of 25, haha, out of 10? 5 and 5. Now we notice, are these the same factors?
Yes, sir.
So as we go about now, and we put we can use our shortcut here. Why can we use our shortcut?
Because the X is 1.
Yep, our a is 1, our leading coefficient is 1, the number with the x squared is 1. So what can I write here for my shortcut?
X plus 5.
X plus 5 and x, no? Plus 5, we follow the sign that's there. X plus 5 and x plus 5. And if we went through and we multiplied this back out, we'd get the original answer.
Yep.
Now you can also write this, or is this the same thing in these parentheses? X plus 5 and x plus 5? Yeah. You can also write this as x plus 5 squared, right? Either one of those is the answer. Either one of those is the answer. Okay? These is the same thing. Okay? Now number 2 is our A1. Is our A1. No, it's 4. We have to go the long way, but let's make our x. What goes to the top? 36. What goes to the bottom? Yeah, 12. What kind of numbers are we going to have on our sides? Let's make that. Negative and a? Negative. 2 negatives, same sign has to multiply to a positive. Okay? What numbers do we think of 36, 6, and 6? Very good, Presley. It's the same number, isn't it? Okay? Now one hint that's exactly the same is 4a squared a perfect square? And is 9 a perfect square? So if the first and last, the a and the c are perfect squares, we'll probably end up having the same numbers. So it's good to look out for. So we're going to separate it. We're going to rewrite and group. So 4a squared minus 6a plus 9. Remember I split the middle term because what's negative 6a minus 6a? What would negative 6a minus 6a be? Negative 12a, which is the middle. Group the first 2 and the last 2. GCF of 4a squared minus 6a? 2a. Let's flip 2 minus 3. What's the GCF of negative 6a plus 9?
3 and
Negative 3. And we're left with 2a minus 3. We always want the first part in the parentheses to be positive. So do we have, this would be a 2a minus 3, not a 2 minus 3. Let me fix that. Do we have the same thing in the parentheses? Gucci. Use that as a new GCF. 2a minus 3 in the first parenthesis. What goes in the next?
2a plus 3.
Nope.
2a minus
2a
3.
minus 3. Don't confuse this with the difference of 2 squares. This is business as normal. So do we have the same thing in the parentheses exactly?
Yeah.
So we could just write 2a minus 3 quantity squared. Either one of these is the right answer. Either one of these is the right answer. Questions on that?
No.
Okay. How many guys try number 3? When you're done or have questions, raise your hand.